Hi guys, in the next session we want to improve our calculator so that it also supports variables and assignments, and for that we have to improve the data structure for expression nodes so that we have a ready to use component for that. And actually this improvement of this expression nodes is an exercise for you, and this video is about giving you some guidance for this exercise. Of course you should have an idea what needs to be changed in the implementation and the interface of the expression nodes and how to test it. And the idea is that you basically do in the test manually, but in the next session gets done automatically by the parser. And here in this video I want to give you an idea how a parser will handle an expression like that. For each identifier it will call this function symadd, so it will generate a new symbol if this symbol doesn't already exist. And in the test, you will do this manually like that. You simply call this function, and afterwards you generate a new expression node. So that means we have a new kind of expression and we have a new constructor. So two things change. We have a new constant for this new expression kind and we have a new constructor. Then we need another enum constant because we also have a new kind of binary node for this assignment. So that means we have two additional enum constants and one additional constructor. So this change in the interface and this change. Then you also have to know that the parser is not only checking in the next session the grammar, it's also doing some semantic checks. This will be kind of a requirement. The grammar that we specify will allow that on the left-hand side we have something which is not a L value. So the grammar is here not violated, but we still need to trigger an error message, L value expected, yeah, and this semantic check gets actually done by the parser. And we have to support that by a function, by a method that gives us a Boolean back, whether it's a L value or not, this expression. So this is another change in the interface, and actually that's all that we have to change in the interface. So the interface will change not by just adding new enum constants and a new constructor, but also by this method. Of course, this method is kind of simple to implement. The only L value that we allow is a variable. That means this function simply returns true if the expression kind is identifier and otherwise false. The better than nothing test that I would suggest therefore would be the following. You have these two assignment expressions and you set them up both manually. And then of course you also have to think about that you have to update the implementations of this print expression tree and eval expression. And probably the print expression tree function is kind of simpler to implement because you just have to add new cases how to print an expression node, but you do not have to think about assigning values to symbols. So I first would begin with something like that you comment this eval function calls, and also currently in the implementation of print expression tree we also call this function. So maybe you change this implementation so that print expression tree just prints the tree. Then you see already something that it works. And after this is successfully done, then you uncomment this function calls and implement eval expression. And of course, I would first check whether your test compiles before you start with the implementation. Of course, you get linker errors, but you should not get compile errors. But after that, you can start with the implementation, and here I would, of course, start with the structure for representing expression nodes. This needs to be updated. So far, we just have one kind of expression node that is actually a primary expression. Now we have two. So what we do is this member for literals will be wrapped in a struct primary, and in this struct we also put this other kind of primary expression node, the identifiers. And that means in your methods you first check whether you have a primary node that is a literal or identifier, and then you can access these two members like that. And of course, if this is too verbose for you, if you don't like this long notation, then feel free to use anonymous members like this or even like that.